Good morning, class. We're going to continue our discussion on trig equations, and today we're going to talk a little bit more algebraic type equations. So we're asked to solve this equation in this interval, and I'm actually going to make that an open parenthesis. As 0 and 2 pi are the same value, so we're going to open that up. Okay, so we're given cosine of x times sine of x equal 3 sine of x. In order to solve this, I'm going to move this over, and I'm going to try to get this equation equal to 0. So I am subtracting 3 sine of x to make this equal 0. And what I have here is going to be a type of equation, and think about algebra. I'll be able to factor out a sine of x I have a sign in each term, and that allows me to factor that term out. So I factor out a sign. From here, because I have it equal to 0, is what we did way back in algebra, or I could set each factor equal to 0. And all I gotta do is solve. So this first factor, sine of x equal to 0, now I gotta think about the sine graph, and I have to figure out what angle gives me a 0. So if you close your eyes and look at the sine graph, we should be able to see that the sine graph is equal to 0 at 0. The sine graph is also equal to 0 at pi, and the sine graph is also equal to 0 at 2 pi, and at 3 pi, and at 4 pi, and every single pi after that. As a matter of fact, it could also be 0 at negative pi. And because I'm given the interval, and I'm only asked to find solutions in that interval, that's why I make this open, so I wouldn't include the 2 pi. The only solutions that will work in the interval is that one and that one. Not that, because it's not in my interval. Now, oh, by the way, in case you could not see the sine graph, and I told you to look at it and I didn't show you the sine graph, here it is again. So from the sine graph, it is 0 here, here, and here. I have another factor I need to deal with. That cosine of x minus 3 equal to 0. So I'm going to solve this. I'm going to add 3. And now I got to think about this. Cosine of x equal 3. And if you look at the cosine graph and find out what angle is it 3. And if you look at the cosine graph, you should realize that the cosine is not 3. It's never going to be 3. As a matter of fact, the cosine graph is stuck between -1 and 1. The range of the cosine graph is from -1 to 1. It's never going to be 3. So this does not give me any solutions. So the only values that will work are x equals 0 and x equals pi. I'll try another one. Now I have 2 cosine squared plus cosine of x minus 1 equal to 0. And I want you to think about algebra. This is a quadratic equation because it's a power 2. And we can solve this quadratic equation by factoring. Now I know you probably haven't factored anything with trig functions in it, but you should look at that and think about this. Think about trying to factor 2 x squared plus x minus 1. Because this is algebra. You could factor that. This would factor And I know there's a lot of factoring techniques that you might be using. I suggest you pause and try to factor this. And when you factor that, you should get that. Okay, so I paused the video for a sec because the video was kind of lagging. So this equation, we should be able to factor to that. Now, if I see this equation, the type of factoring will be the same. Instead of having x, because that's the variable here, I have cosine, because that's the variable function there. So I'm going to factor that. 2 cosine of x minus 1 cosine of x plus 1. Yes, that is equal to 0. So when we have this type of equation, I will probably write this on the side and think about factoring this first before I factor that. So now, set that equal to 0, set that equal to 0, and I have to solve. I was able to add 1 to both sides and then divide by the 2. Here, I'm going to subtract 1, and now I have to figure out what angles will work. So first one, I have a cosine of x equal to 1/2, a positive 1/2. And the cosine is positive in 2 different quadrants. I could be in quadrant 1. I could also be in quadrant 4. So find the angle that gives you 1/2 in each quadrant. Cosine is the adjacent and hypotenuse. And I know that this is a special triangle. And I know that this angle will be 60 degrees. I gotta convert that to a radian, so convert that to radian. If I'm quadrant 4, idea will be the same. I have adjacent, I have hypotenuse. This angle is only the reference angle. The actual angle that I'm looking for will be 300 degrees. We got to convert to radians. Okay, so let's talk about this one. Well, maybe we should convert right now. 60 degrees (300 degrees) convert to radian. The other factor, cosine of x equals -1. So close your eyes, look at the cosine graph, and find out when it's equal to -1. So we should have 3 angles that will satisfy this equation, or that will solve this equation. Pi over 3, 5 pi over 3, and the other angle that I just found, which would be x equal pi. We're going to do another one. Now for the next one, we have to remember that purple paper, so if you don't have it in front of you, pause and go get that purple paper. There are going to be some identities that you need to be able to use. So on this problem, I see a cosine and I see a sine, two different functions. But because I know that purple paper, I can change one of the functions. I'm going to change that cosine squared to something that has a sine. And I'm doing that because I want to be able to solve this equation and I have to be dealing with the same function. So I'm change cosine squared. I'm going to distribute into 2. I'm going to rewrite it, manipulate it a little bit. So pause and do a little bit of algebra. And then we got to be able to factor that. Remember, think about that as an algebraic equation with variable of x. So factor this one, and then you can see how you factor the original one that we need. Pause, do a little bit of algebra. If you're able to factor this, then we should be able to look at that and factor that as well. The difference, the variable on this equation will x's. The variable in this equation is sine. Set each one equal to 0 and solve the equation. Think about when the sine is a positive 1/2. It is positive in 2 different quadrants. It is positive in quadrant 1. It is positive in quadrant 2. The sine is opposite and hypotenuse. This angle we should have memorized 30 degrees. Make sure we convert to radian. So we have a quadrant 2. Now be careful because this is a reference angle. The real angle that we're looking for is 150 degrees. And both of those need to be converted to radian measure. So 30 degrees (150 degrees) so convert it. Right? Now we have the other piece. We're not done here. I got to look at the sine graph and figure out when the sine graph will equal to -1. And I know I tell you guys, close your eyes, look at the sine graph. The sine graph will be -1 at 3 pi over 2. So we should have three angles here. We're going to do one more. So actually, before I go to the next one, if you're dealing with two functions, two different functions, we like to convert one of them into the other. Cosine squared, we're able to convert it into sine. And that way, we're able to factor this equation. Keep that in mind when you look at number 4, or the next one. Because here, there's no way to convert the cosine into a sine, or the sine into a cosine. Remember, the Pythagorean identities only work when they're power 2. So then, we got to do a little bit more, we got to be a little bit more creative. To start, I'm going to ask you to square both sides. And when we square both sides, we're going to get cosine squared of x, which will allow me to change that. Now I could change it. Now I could change that to 1 minus sine squared. But I'll do that in the other step. Sine of x minus 1 quantity squared. Write the parentheses 2 times. Do this derivative property. Combine like terms. We should be getting that. So now, again, I'm going to ask you to pause, do a little bit of work. We have to change the cosine squared into 1 minus sine squared. And then I'll be moving everything over to one side. And then I'll be able to factor, I hope. So pause and do a little bit of work. So looking at this problem, I only have two terms, and both of the terms have a sign, and a 2 as a matter of fact. So I can factor out a 2 sine of x. And this is algebra. And I could solve each equation, or each factor. So each factor equal to 0. And this one I'm going to divide by 2. So I have sine of x equals 0, sine of x equal to 1. Think about the sine graph. Think about the sine graph. The sine graph will equal to 0. The sine graph will equal to 0 a whole bunch of times, and remember that I could keep on going and go 2 pi, 3 pi, 4 pi. The sine of x is equal to 1 pi over 2, because I'm still with that interval. So now we're going to have another problem. When I squared both sides at the very beginning, I introduced an extraneous root. And to figure out which one of these is an extraneous root, I need to substitute in the 0 into the original to see if it works. I need to substitute pi into the original, see if it works, and substitute pi over 2 into the original to see if it works. And when you do that, pause, do the algebra. This will work. And I believe this one also worked. Not x equals 0. Okay. So we did 4 examples. I'm going to give you some homework. And this homework is in the book. And if you have any questions, let me know and then we'll work some out together.